So welcome everybody to the fifth week of the data science program. It's really nice to have you all here again. And I believe your week was fruitful and you enjoyed your week outside the data science program, right? So, and also for the assignments, I hope you're able to do your assignments. I actually just finished with marking the assignment, right? It was actually a lot. So I saw what you guys did and what everyone did. It was quite impressive how far we've gone, and um, the level of knowledge that most of us have gotten to. It's uploadable and it's very loadable. So I'm also going to be talking about the assignments like in a minute. Right. So just a quick one. Just a quick one. Um, Currently we are now aligned, right? So the old students and the new students are now aligned in the sense that they don't have any backlog again. So I would personally want to appreciate the efforts of the new student. It wasn't easy. Like combining assignments, materials, class recording, and everything just to meet up is not easy. It is not easy. And the thing is that it reflects the effort is actually reflecting in their assignment, and it's showing that they put a lot of work to it, right? So it wasn't just something that was done quickly or done just to fulfill our righteousness. Most of them were actually doing very well in the assignment, and it's very, very, very laudable. I really want to appreciate the new student for such an effort. Please keep it up, and also the old students too for also guiding and helping them, right? So at this point we don't have any backlog again, so everyone have, is currently updated, right, with the curriculum, with the assignments, and with everything. So moving forward, we are going to be having a single assignment for everybody. Previously, we are having separate assignments because I won't give the same assignment to the new students. So I gave a different assignment each week. The previous week for the new students, and then a different one for the old student, right? So moving on from now on, we'll be having a single assignment. And for this week, we'll be doing something different, right? Although it will still be an assignment, but it will be more of a hands-on, practical assignment. You'll be analyzing data. You'll be analyzing real-world data. This is not just a conceptual assignment where you just have to practice your knowledge on some Python concepts, right? I'll be giving us data to work with, right? So after we are done for this week's sessions, you would have what it takes to do that, right? So it will kind of help you form a foundation on doing data analysis, right, as we move forward. Because next week we'll be entering into machine learning. You all know this is a data science course, so there's no way we are not going to do machine learning. So I really want us to start that as soon as possible. All right, so that's it. Let's just go straight to assignment correction as usual. All right, so I'm going to share my screen. All right, great. So as I usually do, I pick an assignment that I like and use it for the correction. Um, for several reasons. One, not to waste time manually going through the assignments, and two, to also appreciate your efforts too. Is a way of also appreciating your effort, because once you see that your assignment is being used there, you'll be motivated, right? And you'll be encouraged to do more, and others as well. All right. So last week we talked about NumPy and Pandas. Right? We wrapped up with NumPy and we entered Pandas for data analysis. So I gave us an assignment on on NumPy as well as Pandas, right? Although we didn't finish Pandas last week, so we'll be continuing from there today. But we're going to just be going through the assignment and making some correction. I really feel that this assignment is a little bit ahead, a step further of the previous assignments we've been doing. So this actually requires you to calm down, read the questions, go through the materials, go through textbooks, and just understand the concept before answering it. So I believe if you did this assignment, you definitely be confident with some of the things that we've done so far. So because of time, I would quickly go through this assignment. There's actually a lot to discuss in this assignment. So the reason why I do the correction for assignment is to actually revise what we've done, right? And also show you that particular area where you probably didn't answer well, and take corrections on that, and we move ahead. Right. So for the question one, I asked us to let me zoom. All right, so I asked us to write a NumPy program that creates an array of 20 random integers between 10 and 50. All right, so now there's some things to take notes here. I said random, right? Random integers. So you can't use linspace for this. Right, in case you did that, you can use linspace. So I was actually trying to test your understanding of the random function or the random module we discussed last week. Right. So after that, you create the array, then you calculate the sum, mean, standard deviation, and variance of the element in the array and print them. Usually, it's a straightforward question. So the way you do it is just np.random.randint. Then your starting point 10. And your ending point 51. I don't need to explain that to you again, right? And then the number of elements 20. So you create the array, and for that array, you are going to get the sum, the mean, the standard deviation, and the variance. So these are statistical functions, right? That I explained in the last class. So it shouldn't be a problem. So you should be getting everybody won't get the same answer, right? Because this is a random operation. So if two persons do the same thing, they will get different values because it's a random operation. The numbers are generated at random, right? But I will later teach you how to make your work reproducible, right? We'll get to that later. But for now, just know that no two persons will get exactly the same set of number. So this should be what you'll be getting: your sum, which is adding all numbers, the mean, the standard deviation, and the variance, right? So as you can see, this is a long decimal number. So you could have as well rounded it up, but it was not part of the question, so that's fine. Question two. Create a 2D. This question is quite tricky, but just pay attention. Create a 2D NumPy array with random values between 5 and 15 with a shape of 4 and 4. That is 4 rows and column, right? Use NumPy to find the minimum and maximum values, both column-wise and row-wise. So now, this can be a very tricky question. Like, what do I mean by that? So column-wise and row-wise, they mean different things from rows and columns, right? So let's just go into it. So now I give you an idea of how to do it, right? So just to help you with that. So now you create your random array, right? You already know how to create, but in this case, your size here would be 4 by 4, right? Because this is a two-dimensional array. So you have a 4 by 4 array. Then for your row-wise, right, you would be using axis 1 as your axis, right? So just try to understand this. You are trying to get the minimum across each row, right? You are trying to get the minimum approach row. So what you'll be doing is trying to aggregate, like you try to aggregate by column. Like you try to aggregate the columns to get a single line of rows. That is why your axis here is 1 instead of 0, right? It's 1 because you're trying to aggregate the columns to give you a single row, basically. So that is basically what this means, right? So I'm finding the minimum and maximum for your row, for that particular row. So the same thing for column. You aggregate by row. Right? So when you have your columns and you want to get a single value for your column, you aggregate all the rows to give you a single column. That is why you have 0 here. So this axis 0 mean aggregate by row, and this axis equal to 1 means aggregate by column, right? So that should do for that, right? So we don't want to waste much time. So that is basically the array, and then we have your answers here. And you can see you have a list of values, right? The function basically aggregated this entire array to a single line or a single array, one-dimensional array for both the rows and column. So let's move on because of time. Number 3, create a Pandas series from a list of temperatures, right? It's given here, and label the indexes as Monday, Tuesday to Sunday. All right, and also the data type should be float. We did this in the last class, so you should be able to do that. You understand how to create a series, Pandas series data frame. So basically, this is just it. No biggie there. All right, so the next one is construct a Pandas series, right? The same Pandas series with 20 numbers from the 100 to 150. So in this case, I didn't tell you to use random numbers, right? I didn't tell you to create random numbers, right? So you can either use, there are several methods, there are different ways to do it. You can either use linspace, you can as well use random, np.random.randint, anyone will serve, right? Then what you just need to do is just make sure that your value does not exceed 100 and 150. It's between 100 and 150, and it's also 20 values. So and after that, you just specify the data type to be upload 64. So you should be getting something like this, right? 20 values, 20 values. So this is the index number, and these are the values. So very simple. So for question 5, create a Pandas data frame with 10 rows, and yeah, so these are the columns, these are the variables to populate, right? So the first question, the first variable, I specify that your name should be the first. And this is it's some persons didn't do that. I don't know why, but your name should be the first here. I did that for a reason, right? So this should be how your data frame would be, right? But there's something I'll quickly tell you about data frame in Pandas. Whenever you use print to print your data frame, you're going to get a very bland printout or output rather. Like it will just be like a normal text output, text output without any formatting. But if you do that without print, let's try to do that here. Okay, we have to import all these things. Okay, import pandas. All right, so you see it gives us this beautiful formatting. Right, so print actually removes this formatting and just gives you the plain text. But if you if you just type out the data frame, you are going to get something like this. But there's a function that you need to know about. It's called display. Display. So it's basically used for your data frame. So whenever you use display, your data frame would also always be displayed as this. So take note from today. Instead of using print for your data frame, use display for it. Instead of using print, use display. So just take note of this, right? For next time, right? So you would have a more appealing data frame. All right. So the next question is to print out the shape, the columns and the data types of the data frame you created already. So for that, you should have 10 by 6. So you have 10 rows and 6 columns. And then these are the columns, right? So you have your data types here too. Should I adjust it for that? And question 7, basically this is for operations in um, series. So basically, you have to create two series here and perform this operation, sum, difference, and product. So yeah, these are just what we did last week, and I believe everyone already has an understanding of that. So the hello, can you all see my screen? So someone is saying it's showing the same thing. Please let me be sure that it's not from my own end.
Mm. You're seeing your screen.
All right, all right, all right. Thank you. So, question 8, you are asked to list out the attributes or methods of a series. And I said, don't include the ones we talked about in the last class. So I needed you to, these assignments are a way to just push you to read or to practice, right? I needed you to like explore other functions we have in series and methods, right? So these are some of the things that this person brought out. I saw some persons bringing out those variables, sorry, those methods that have underscore, underscore. I remember I said it several times that you don't have any business to do with those ones for now. Like for the course of this, for the sake of this purpose of this program, you don't have any business with those things. Like if there is any need for it, I will let you know. For now, the ones you should pay attention to are the ones without underscore. Like so, these ones that you are seeing here that are just normal text. So yeah, just note that too. So the same thing for data frame. And I believe as you did this, you also were able to explore and as well practice each of these functions, seeing what they can do, right? Because most of the things you'll be doing in Pandas is using Pandas functions. Like that is just it. Yeah, you basically be using Pandas functions almost for your data analysis. So question 10, basically I asked you to list two key points you learned in week 4 classes. I wanted our assignment to not just be technical. I want to hear you. I want to hear what you have to say. So for those that just said I learned Python and I learned NumPy, I don't understand. Those are not specific points. It's not specific. I'm asking for specific points. In Pandas and NumPy, what did you learn? Right? So what did you learn? So in case you find yourself not getting what you want, all these things should give you an idea of where you missed it. So that's it for the assignment. We will be going into what we have for today. We'll continue from where we stopped last week, right? Um, we started with pandas for data analysis. We talked about um, pandas, the overview, went to the data structure, talked about pandas series, and we as well talked about a little bit about pandas data frame, right? But we didn't go into this. So today we'll be starting with the basic data frame operations. So let me just give you an idea of what we're going to do today. We're going to wrap up with the concepts in the remaining concepts here. And we're going to practice. I'm going to illustrate how you do data analysis with a real data, right? With a real data. So let's just move on. So I believe we all already have an understanding of all these data structures, NumPy, sorry, pandas, and how it is built on top of NumPy. And pandas series is homogeneous in nature. It just has one column and an index with it, right? So all these characteristics and everything, and we also did basic operations on series and a lot of other things, right? Yeah, so for today, we are going to be continuing with DataFrame. I think we stopped here. Am I right? We stopped here. Basic operations, basic DataFrame operations. Please let me know in the comments, sorry, in the class, in the chat, if I'm correct. If I'm not, please let me know exactly where we stopped. All right. Just one person. Okay, okay. All right, great. Yeah, so for today we're going to be looking at DataFrame. DataFrame is the main aspect of Pandas. Although we've introduced it last week, but we're going to go deeper. We're going to see the capabilities of a data frame, what a data frame can do, and what a data frame cannot do, right? So by the end of this lecture today, you should be comfortable. You should be comfortable working with a data frame, right? And yeah, there are resources, right? The textbook and all other things, materials I have sent. So all this should help you, give you an intuition on how to work with the data frame. So we are going to be looking at viewing our data. So let's just create a basic data frame here. Let me see if there's already one. Okay, we have one here. Let me quickly create this. All right, so I'm going to just adjust this to um, all right, it's 246, 246. All right, so no, I don't know. I forgot how to spell engineer. So 2, 4, and we are dot. So all right, so this is a dictionary. I'm going to create a data frame from it. Data dots. Okay. All right. So just to lighten up the class, what function would I use to create a data frame from this data? What function pd dot? What am I going to use to create the data? I want to create a data frame from this particular. So what function am I going to use here? And specify the cases how it is going to be written syntactically. Can I get responses in the group chat? All right, exactly. So pd.dataFrame. Ensure that your data frame follows the correct case. D is in capital letter, F is in capital letter, right? So we'll put a pass in our data there, and then we'll run it. What? It will give me an error, right? Why? Why? Can someone tell me why this is giving me an error? Quick one. Can someone tell me why this particular code is giving me an error? Someone say data is not defined, but this is data. We just define data now. Yeah, exactly, exactly. We didn't import data and pandas, so that's very very important. So we have to import pandas as PD. Exactly. So um so yeah. So this is all right. So this is what we're going to have. We printed it out. So let's assign it to a variable that is df. Right. So we have our data frame now. So now we want to view our data. So when you have a data frame, let's assume I don't want to go straight into using a real life data. Like I want to walk us through from the basics. And then when I start in this same session, I'm going to use a real life data to illustrate all this. So when I do that, you would understand it very well. So when you have you import your data, most time you are not going to define your data in pandas. Like this is just for teaching purposes. In real life cases, you will not be defining data in a dictionary. You rather be importing your data from Excel file or from a CSV file or from whatever file format it is that your data is stored in. So when you import your data, this is not going to open an Excel spreadsheet for you to see your data, right? So it is there in memory. So for you to see your data, you have to use certain functions in pandas. So one of the functions in pandas you can use to view your data is called df.head. So what df.head does is that it shows you, it prints out the top 5 by default. It prints out the top 5 rows for you. So it prints out the top 5 rows, right? So if I run this, I'm going to get the top 5 rows. So I can see John, Anna, Peter, so 0, 1, 2, 3, 4. So these are the top 5 rows. Remember, we have 5, 6 observation, but it's printing out just the 5, right? So we can actually modify it here. If I come here and put 2, arbitrary, it is going to just print the top 3 rows, right? So we have 3 here, so it will print the top 3. So this is a way to view your data, because sometimes you might have a very large data set, like thousands of rows, 10,000 rows, 20,000 rows, 30,000 rows. So you can't see everything at once. So you want to have a glimpse, an idea of what your data frame is. So you use your df.head to see it first. Okay, this is what it looks like. These are the columns, these are the rows, right? So it's just to give you a visual understanding of your data, to help you appreciate it visually. So that is for head. So we also have df.tail. df.tail does the same thing, right? It prints out the last 5 rows by default. So if I run this, you see I'm going to get from 5 to 1. 0 is not there, right? So it to print out the last 5 by default. But if I put any number here, that is the number is going to print. If I put 3, you're going to print out just the last 3 rows, right? You're going to print out just the last 3 rows. Is the network disturbing this class, or is it just specific individuals? I want to be sure. Is the network disrupting the class? All right, perfect. So that's what your df.tail will do. It will give you the last 3 rows. All right, so that's for viewing your data. So don't worry, we are going to do a lot today. Like, just buckle yourself. You're going to see pandas in action today. We're just starting. You're going to see a lot. All right, so but let me just give you an introduction on some of these things. All right, so that's it for viewing your data. You can also select rows and columns. So you can select rows and columns. So the way to do that is by using the the column name, the variable name as an index. Remember when we were doing NumPy and we want to index a particular value, we're going to use numbers, right? But in data frame, when you want to index or you want to get a particular column, we use the column name. Pandas makes it easier for us. So we can just say df then your bracket as if you want to index, right? And then you would say you want to get just this age column. You just say age, right? Age, and then and it will give you all the values for age. Let's say you want to say you want to get occupation. To give you all the occupations of all the observations here, right? So there are instances or situations where you have analysis. I want to work on specific variables, right? This is what you're going to be using. You can just get slice out this particular column. You can even assign it to a variable. You can come here and say occupation. You can assign it to a variable and start working with it, right? So basically, Pandas is flexible, very, very flexible. So that is how to get columns or slice out columns from a data frame. Why for rows? To get your rows, you basically, there are several ways, but this is the most common way. You do df.iloc, right? So iloc basically I here means index, while loc mean location. So iloc mean, let me just put it here. Iloc mean index location, right? So for your rows, you use iloc, and then once you put once you like type out the iloc, you will now put your square brackets, right? And then specify the row you want to slice out. Let's say I want to slice out this this fifth row that is index 4. I'll just put 4 there, right? And I will get this. So this is the fourth so this is the fourth row. So it has 3 variables, and the observation there is Musa, age, and occupation, right? So this is basically how to get a particular row. If I want to get 2 rows or more than 1 row, I'll just use the colon and then indicate where I want to start. I want to stop, right? So the same thing for normal indexing. So if you already know how to index, this is not going to be a problem for you. The only new thing we're introducing here now, let me zoom in well. So the new thing we're introducing here is iloc, right? It means index location. So you just come here and say let's say I want to start from index 1 to index 4. So if you run it, it's going to give you from 1 to 4, right? Sorry, from 1 to 3. Remember, Python doesn't include the last index that you specify. So to give you from 1 to 3. So this is how to select specific rows in your data frame. So this is how to select your column, and this is how to select your row. If you look at other materials or other tutorials, you see several other ways to do the same thing. There are plenty of other ways to do it, but I don't want to bug you with so much information, but this is just the fundamental way of doing index location and getting or slicing out a column from a data frame. So just know this one. You can explore other ones in the textbook and also in other resources, right? So yeah, that's it for that, for getting rows and columns from your data frame. So let me quickly add something. So for viewing data, there's another function I forgot to talk about. It is called df.sample. df.sample. And what df.sample does is that it randomly samples a particular row from your data frame. So if I say df.sample, it will do sample just 1 to give me 1 row. If I do it again, to randomly give me another row. So if I do it again, to randomly give me, so it just, all these things just to help you see your data, like different parts of your data. So if you have like 10,000 rows, you can be using this sample function to randomly check how your data is, like the kind of information that is in your data frame. So if I put a value here, by default, it gives us just one row. But if I put a value, if I put 4, it will sample 4 random observations or rows. If I run this, I'm going to get this randomly. If I run this, it's going to give me this randomly. If I run, so basically it samples at random. So this is just something you also need to know. It's going to help you while analyzing your data. So something you need to know about all these libraries, most of the things you'll be interacting with are functions, like the functions of that, the object you are using for that particular library. So you have to understand all this. Definitely, you won't know all the functions, you won't know all the methods, and that is perfectly fine. But just try to know those most important functions that you would be needing for your data analysis, right? You can always look them up if you forget anyone, right? So yeah, so that is it for that. Let's move on. For selecting columns and rows. So there's what we call Boolean indexing. So remember what Boolean is. Can someone tell me what the Boolean is again? In the live class, can you tell us what Boolean is? Okay. Exactly. Boolean is not a statement. It is not a true or false statement. Boolean is a data type. It's just like a float, or it's just like an integer. Boolean is a data type that has two values, possible values, which is true or what? False. So a Boolean is a data type that has two different values, true or false, right? So you might not necessarily be using it directly, but there are a lot of instances where you will be using Boolean or interacting with Boolean indexing, right? So let me just quickly go here. All right, so for Boolean indexing, now, what do you mean by Boolean indexing? So that sometimes you want to select. Boolean indexing is a way of selecting specific data from based on a condition from your data set, right? So let's say we want to select only those people that are less than age 25. We want to select only those people in our data frame that are less than age 25. We can use Boolean indexing. So we can come here and say df, right? Age. So because we were working with the age, right? So we'll just come and say age, and then we'll say less than 25. So this is, you can actually do this in your data frame. It will give you true or false Boolean values. So this false mean this particular index here is greater than 25. Is only one true that we have here. But we can't use this for anything. This doesn't make sense, right? So the way to get the actual value is by using this result as an index. So we'll come here and type out df again and put it inside a bracket, put that result inside a bracket, and we'll run it. And we're now going to get the truth or the true value in our data frame. So this is the only person that is under the age of 25 in our data set. So Boolean indexing is a very, very, very nice way of selecting specific data from a data set, right? You get, so we can change this and say greater than let's say 35. I'm going to get something else, right? So you can see it gives us these two values, these two observation of persons. So Musa and Chidinma. So 57, 56, 78, right? So this is very nice. There are a lot of things we can do with Boolean indexing. So just understand that. I'm just introducing different concepts that you'll be needing for data analysis. So once we start with the data we have for today, you understand and appreciate the data. All right. So next thing we have here is data manipulation, right? So we can do a lot of things with our data. We can add or remove columns, right? So basically we can add, remove column. We can remove from missing data, right? I'm going to tell you exactly how to work with missing data. So just pay attention. We're going to talk about this. So we're also going to talk about data aggregation and group operations. So now for data manipulation, adding and removing columns. So we can actually add a new column, right, to our data frame. So let me come here now. We already have let's say df. Let me print df. So remember display df. Right, so this is our data frame. So this data frame, don't mind it, it is very small. Once we start working with, you see how large they are. So this is our data frame. I want to add another column to it. I want to add another column. Let's say we want to add male and gender. I want to add gender. So we can just quickly come here. Instead of going to define to our dictionary here and start adding it, we can directly add it to our data frame with this syntax, adding a new data frame. So we can come here and say df, and then you specify the name of the new variable or the new column you want to add. Let's say gender, right? Equal to, then you are now going to list out the values. So you make sure that it is the same number of index with your existing data frame, right? So if I come here and say male, okay, let's say job male, female, then we have male, female. We have male, female. Right. So what we've done now, we added a new column to our data set. So if I print our data frame out, you're going to see gender, right? I've added gender to our data frame. So if let's say I remove one observation there and I include it, like it is not the same length as your existing data frame, it's going to give us an error. So that is just one thing I need to know. Make sure that in case you are adding, or most of the time, you're not going to do it manually. Your data frame, you are going to create new column based on an existing column, right? So I can come here and just put the female. So I'll then have a new data frame. Okay, let's now say I want to add another column again, right? Based on this age. So I want to add, let's say I want to add a new column that will have the age of these people, but we are going to add 5 to it. Like we are going to add 5 to each of their age, but it's going to be a new column. So I can come here and say df dot age age 5, let's just say age 5, right? And I'll come and say, okay, it's based on this our age column bar. I'll say df age. I think this should work. So what we did now is that we added 5 to every observation here in our age column, and we assigned the output to a new variable here. So if we print our data frame, let me come here and print our data frame. Remember display. You see, we are going to see a new column here that is based on this existing column. So I'm just trying to give you an idea of how you are going to be manipulating your data frame when you are doing analysis. you can be creating new column based on existing column. For instance, now I think for those that know one or two things about accounting and finance, there are some variables that let's say you want to calculate profit. Let's say you're running a business and you want to calculate profit. Profit is revenue minus what? I think is it sales or something? I don't know. But there's a way you calculate profit, right? So, and let's say in your data frame, you already have your revenue column, and then you already have your sales column, right? And you don't have your profit column, but you need your profit column. Okay, revenue minus cost. Yes, yeah, thank you. So revenue minus cost. So you have your revenue column and you have your cost column, right? So you would to get a new column, that is your profit column, because you want to use that profit column for your analysis, but you don't have it. You can create a new column by subtracting cost, the column of cost from the column of revenue, and assigning the output to a new column that is going to be called profit. Hope everyone is following. So basically, you can perform these operations on the columns in the data frame and have results based on what you want. So it is a very, very interesting thing. A lot of capabilities in Pandas. So we're even just getting started. So that is it for adding columns. So let me quickly go through this because I need to start with the data we have. Right. So now we have what we call, we can remove a column, right? As we can add, we can also remove a column. So the function here is drop, right? Drop. So if we come here, let's say we want to drop this our H5 column, we don't want it, or maybe we have a data and there are columns that we don't really need. That just it is not necessary for our analysis. We can just drop it, right? So to just help computation to be faster. So I can come here and say dropping a colon. We're going to come here and say df.drop. So this is the function for this. So in Pandas and in other libraries, most of the libraries are going to be using, what you just need to learn most time is these functions, the different functions. That's why when I asked you to get 10 attributes of the series and 10 attributes of the data frame, I'm not just telling you to just go and just for assignment's sake. I needed you to get conversant with them, to get to know the different things you can do with a data frame or a series, right? So because that's what you'll be interacting with mostly. So to drop a column, just come here, def.drop, and then you will specify the name of the column. Now, there's something I talk about initially. So to get names of all your columns in a data frame, there's a function for that. So the function is df.columns. I think we did this before. Okay, yeah, we did it last week. Yeah, we did it last. So to get your columns, you just say df.column. Let's remove this. So in case when you are working and you forgot some of your columns, like let's say your table, you don't want to start displaying your table, but you want to do something on your column. You can quickly use df.columns to get all your column names, and you can say, oh, this is the column I want to remove. I want to remove this H5. Then you just come here and say, you can put print here, so it will always show, right? So you say df.drop, then the column name age 5, right? And followed by the axis. The axis is what? What axis am I going to put here? 1 or 0? Exactly, 1. Exactly. So your axis should be 1. So if I run this, I'm going to get my column will be dropped. So this is what we're going to have here. We're going to have our data frame without the last column. But there's something you need to know. Pay attention. This is very, very important. In Pandas, once you perform all this operation that changes the structure of a table, right? It is not always permanent. it does not apply to your read data frame, because if I come here now and say display df, remember I've already dropped, I've dropped the colon here, right? So you expect that your data frame will not have that colon again. But if I come here and say display df, it's going to still give me age 5. Like I thought I just dropped this colon. What? I don't understand. Does it have 5 lives? So you'll be wondering what's happening. So in Pandas, there's what we call in place. In place, it is a parameter, an argument, right? And it usually takes a value of either true, what's happening? True or false. So either take true or false, but by default, the value is false. The value is false. So if you want it to apply to your data frame, like the effect should be permanent, right? You would use in place equal to true. In place equal to true. Or yeah, you can just run this. If you run this, you see that it has, as I display my DF now, age is no longer there. So it has applied to my original DF. So you have to be careful when doing analysis in Pandas, because there's some time that you might be working on something. You are trying to manipulate your data frame and change some things. So you made a mistake and you made it permanent. It's going to actually affect your data frame, original data frame. And that was not what you intended to do. So sometimes you need to pay very attention to use this in place. Make sure that, yes, this is what you want to do, right? If you do this and it is not what you want to do, you would have to go to the beginning of your notebook and rerun or re-import your data again. So just take note of that. Take note of that, right? So you can as well, there's also another way of doing it. You can also say df, you can assign the new thing to your data frame. You can say df age 5 and axis equal to 1. So you can also assign it to your data frame, right? Okay, so you see I have dropped it already, so it's giving me an error. So I need to go and rerun this thing here, rerun this one. And I think, where did I add that age? I think I added a new column somewhere. All right, gender, rerun this one. And age, this one. All right, so if I come here now and rerun this, you see, this is another method of dropping, of making it permanent. So you can either use in place, right, inside the function, or you just assign the output of this drop to your data frame, so it will replace your original data frame. So I hope you get that. So that is another thing you can do in Pandas, right? So you can add new colon. You can as well remove new drop colons too. So there are also other things you can do. You can working with missing data is also something that is very common. This one I'm going to leave it, right? I'm going to leave it till when we start with the data we have for today, because there are some things I'll discuss then. All right, so group by, I'm also going to leave this so let me just go straight to CSV file. So these are basically what you're going to be doing in Pandas. It's just for you to have an idea of how flexible and intuitive Pandas is. So now this is actually what you are going to be doing or working with mostly in Pandas. You are going to be working with multiple data sources. So you're not going to be creating a data frame. Nope, you're not going to be creating a dictionary and then converting it to the data frame. What you're going to be doing is to be importing CSV files or Excel file or whatever file it is that you want to analyze. So, but what we work with mostly in Pandas is a CSV file. I don't know if how many of us know what CSV file is. I don't expect everyone to know, but if you know, you can just drop the meaning of CSV in the group chat so others can say. I would love to see that. I would love to see how many of us know what a CSV file is. I don't expect you to know though because we have not talked about it, right? Um, all right, perfect. I think some of us know what it means. All right, so yeah, CSV file is it's called comma separated value. So it's a very, very flexible way of of transporting data, of sending files, different kinds of files. So I believe most of us that work with files, we already come across CSV files in one way or the other, right? So it's different from an Excel file, right? So most of the time, whenever you download the data um from the internet, right, they will mostly be in a CSV file format, right? A CSV file format. At the end of this lecture, I'm going to be showing you where you can download data from, so you can work with different kinds of data, right? I will show you that at the end of the class. So let's just go straight to working with CSV file, right? So now there are things you need to pay attention to now. So let's assume I sent you a data, a CSV file data, and I told you to work with it or use Pandas to analyze it. How do you approach it? Pay attention. Now, this goes beyond just writing code in your notebook. You have to understand how to properly place that file in your computer. You have to understand how to folder. Oh, network. Can everyone hear me? I think my network just went off for a bit there. All right, good. So there's what we call a folder. We all know what a folder is, right? On our computer. So when we download these files and you want to work with it in Pandas, make sure that that file is in the same folder with your code file or with your notebook file. Let's assume your notebook now. The file is saved in Career X folder, and in Career X folder. When you download your CSV file, make sure you save it inside Career X folder too. So because what we are going to be doing is going to require you to do that. Else you are going to be meeting different kind of errors. So now let me just illustrate that to you. Now this is a folder. I can see this is a Career X folder. This is our lecture notebooks so far that I've been using for lectures. As you can see, I have my data set inside in that same folder, right? In this same folder. So this particular notebook I'm working on, this is the notebook I'm working on, this untitled IPYNB. This is what I'm using to illustrate and do all these things I'm doing. And this is where I want to import my data in. So I should make sure that this particular notebook is in the same folder with this my data. So now that is the first thing to do, right? The second thing to do is to take note of the name of this file. The name is retail transaction data set. Take note of the name, the case, if it is capital letter, small letter, if there is underscore, just make sure that you are taking or getting the exact name of the data set. So that is the second thing to do. Next thing to do is to come to your notebook and reading a CSV file with Pandas. So the function that we use to read CSV file in Pandas is pd.read CSV. So this is the function here, pd.read CSV. So what will be in the bracket is what the file name. So the file name is you come here, make sure you get the file name, retail transaction data set. I'll come here and say retail transaction data set .csv. Then you put it in, make sure you put it in quotes, right? Either double quote or single quote. You press enter. As you can see, what am I seeing? I'm getting I'm getting a data frame. As you can see, these are the different columns and these are the rows of the data frame. So this is this particular CSV data. Remember, if you worked with Excel before, this is the kind of thing you are going to be seeing, rows and columns. So you've imported this your data set now into Pandas, and this is how you are going to be working with it, right? So you have your different variable, customer ID, product ID, quantity, price, transaction date, payment method, and so many other things, right? So depending on what you are working on, right? So this is how to import a data in Pandas. If it is Excel file, this place will be read Excel, right? Read Excel. So it will be read Excel dot xlxx, right? So just make sure that you are putting in the correct function for that particular file format. So it's CSV. Most of what we're going to be working with is CSV format. So this is how we're going to. So, but when you read in your data, you don't just leave it like this, right? You assign it to a variable. So you can just name the variable retail DF data frame, and then I've read it. So now I can now work with my data. So this variable I'm going to be using all over. So I can come here and once you do that, just leave that particular cell. This is why Jupyter Notebook is very nice. So you can leave that cell and come to another cell and start your work and say, okay, now there are different stages. I want to give you an idea of how to approach data analysis in Pandas. So you'll not be confused. So where will I start from? Will I start concatenating so to have an idea of the steps to follow, I'm just going to go over them. So once you get your data, the first thing to do, like we've already, so now these steps, data analysis with Pandas typically involves several stages that leverage its functionalities for data manipulation, cleaning, and exploration. So yeah, this is the breakdown of the stages. So the first stage is data acquisition and loading. So what we just did now, what I just explained to you is what we call data loading, like reading your data set. You can name it anything, but you get the idea of what I'm saying, right? You are importing the data you want to work with. So this is it, right? Next stage, as you can see, we have reading data from CSV, Excel, or other file formats using Pandas functions. So Pandas has functions for almost any file format you can think of. JSON, Excel, XML, different things, but CSV is the common one, is the most common. So that's what we use. So you can actually also use Pandas to access directly from a database. There's sometimes in companies that have database, you can just directly access the data from the database. So that one is a different thing entirely. But what we are going to be talking on for this program is reading from files in our local computer. Right. So the next stage now is data exploration. If you were in our first class where I talked about data science lifecycle, you will see that this is following that same pattern, right? This is following that same pattern, right? So this is basically how you approach data analysis in Pandas. So next stage is data exploration and understanding. Note, data exploration is not the same thing as exploratory data analysis. I will say it again. Data exploration is not the same thing as exploratory data analysis. Data exploration is just trying to understand your data, try to get the structure and the content and see the columns that are there, the rows, the shape, and so many other things. But exploratory data analysis is actually doing data analysis, getting insights from your data, and doing a lot of analytics and using analytics techniques on your data frame. So note that, because if you go down here, you see exploratory data analysis is still there, right? So, but the next one after introducing your data is data exploration and understanding. So that's what we're going to do now. So to explore your data, let's come here. I've brought my data into the Python space, into Pandas, right? So exploring the data. So you don't really understand what the data frame is about. Remember in Excel will just show you everything in a workbook. You'll be seeing it directly as you're working with it. But in Python, in programming languages, you can't see it. It is not a graphical user interface. So you have to use code to see it. So the first thing you would do normally is to use df.head, right? As I told you before, to see, because if you just say df, it will print retail df, right? So it will print, if you don't use head, it will print everything, like, but it will like kind of compress it because of space. Right? As you can see, we have 100,000. This is 100,000 rows observation. So as you can see, that's a lot of data. Right? So what you are supposed to do is just use head just to see your data. It just give you the first 5 rows, right? So from 0 to index 0 to 4, or you can say head 3. Just to give you a sense of what your data is. So you can just go through it. Oh, okay, so we have column. So this is what the data in. It's not going to give you an in-depth understanding of your data, but at least will give you a visual representation of what your data is all about, right? So that is the first thing you would normally do. And you can also check. You can also do tail. You can come here and say tail to give you the last 3. See, 99,999. So it gives you the last 3 observations. So you can just check it out, just see it, see the values and everything, right? So you can also use sample, as I said before. Sample would give you randomly. So as you can see, these are random. This is index 99,000 index. So it's random. If I run it again, to give us a random value. So it's just picking at random. If I put 5 here, if I put 5, it's going to give us 5 random. So this is just like help you go over your data to visualize and see it visually, right? So that's the first thing you would normally do, right? So we also have several other functions, right? So you want to understand your data, how many rows and how many columns. So the function for that is retail df dot shape. The same thing as numpy, right? So the shape here is 100,000 by 10. What this means is that it has 100,000 observations, rows, and it has 10 columns. That is 10 variables. So this, it's not say, you cannot be like, my data is plenty. All right, that is great. So you are already getting to understand your data little by little. That is data exploration and understanding. So there's another option again to understand your data. Retail, we can use info, or let's say columns. You want to see all the columns in your data set. You can just use these columns attributes, and it will give you a list of all the columns in your data. So you can see customer ID, product ID, quantity, price. So we have about 10 of them here. So this is a list of all your columns in your data set. So this is just things that you will do when approaching analysis. So this is the first stage. You'll be doing a lot of things, right? So another thing you can do that will give you a comprehensive outlook is using this retail, using dot info. This dot info is a function, right? Shape and columns, these are attributes. Remember, I explained that. Before, right? And I said functions usually come with brackets. So if I say retail df.info, it's going to give me an information about my data set generally. So if I run that, this is what I'm going to get. Let me zoom out. As you can see, this is the output. So the first thing you're seeing here is the class of your object. So this is a data frame. That is a data frame. This is the range index. So you have 100,000 entries from 0 index to 99,999. So we have a total of 10 columns, right? So these are the columns from customer ID to total amount. And this not null basically is saying that we don't have any missing value. Everything is complete. We don't have a missing value yet. But I'm going to tamper with the data and just introduce null value. So I'll explain how to work with missing values, right? So we have count. This count basically is just to tell you Just give you the count basically. So these are the things that you're going to see. This is the data type, right? The data type of each column. Remember I said your um the data frame is heterogeneous. Each column can have different data types, right? So, and if you come here, it gives you a summary of your data type. You have 1, 2, 3, and we have for flow 64, we have 3 columns that are flow 64. We have 2 columns that are in 64, and we have 5 columns that are objects, right? And we also tell you your memory usage. So basically, this data frame uses 7.6 MB in your RAM of your RAM, right? So it is a very large data set. So this is just to give you an idea of the data set you're working with. So you're trying to understand your data. So there's also something else called describe. A describe attribute. So what describe does, is that it gives you a numerical description, a description of all your numerical variables. As you can see, it just gave us for customer ID, quantity, price, and total amount. But in this place, we have more than that number of columns. We have other columns. So it is just the ones that are numerical that this describe function is going to describe. So it's going to give us basic statistics, right? To give us the count of each of them, give us the mean, right? So the mean for this customer ID doesn't really make sense, right? So it's just customer ID, but for the fact that it's numeric, it was included. So it's for quantity. See, quantity is giving us the mean. So this is the main quantity. It's giving us the price, the mean discount, and the mean total amount. So giving us the standard deviation, right, of each of them, and giving us the minimum value. So the least value for price is 10, giving us the max is 99. So basically it's just a descriptive statistics of your data, and you can get that using retaildf.describe, right? So that's just it for that. And this is 25% in percentile, 50% percentile. So these are just basic statistics. So this just introduce you and give you an idea of your data set, right? So these are the things that you mostly be starting with when working with a data. This is just for exploring your data frame, and understanding it. So now, when you've done all this, you should be comfortable that you've understood what your data frame is like, and then you can now proceed to the next step, which is data cleaning and pre-processing. Data cleaning and what pre-processing. So remember, when we talked about data science lifecycle, we talked about data cleaning. So now there's something I just need to say. When you are, as a data scientist or a data analyst, to do data analysis, there should be a question or a problem that precedes it. You don't just do analysis just because you want to do analysis. You do analysis because you want to use the insights from the analysis to solve or to answer a question, right? So when you're coming to do analysis, right, in Pandas, you are being guided by a set of objectives. So you don't just go from one place to another, because there are a lot of things that we can decipher from this particular transaction data set. A lot of things. Maybe this person just wants to understand how much they've made so far, or how much they have been able to make for this particular product in this particular time frame. So there are several questions that can be asked. So when you are given a data set, you'll be asked to use that data set to answer questions. So by the time I give you your task for this particular week, it's going to be more like a project for you, because I'm going to be giving you a set of questions. This is not going to be the one I'll say number 1, number 2, number 3. No, this one I'm going to be giving you a problem description, right? Like a business problem description, and I will give you a data set, and I will tell you that, okay, use this data set to answer this question, these questions. So that is how you are going to be guided in your analysis. So I just wanted to point that out, right? So that's it for exploration, data exploration, and data exploration and understand. So the next thing is data cleaning, right? So data, we have what we call data cleaning. So now, why do we clean our data? Most data are dirty. Most data we come across are dirty. Most data are dirty. They are dirty, they are disorganized, they don't have a structured, a very, very good structured format. The data types are not correct, some of them. So many things. They have duplicate values, they have missing values, they have outliers, like a lot of things can happen. So your data is not always perfect. So when you get the data, you don't just jump to analysis. Once you carry your data like that and do analysis, your results will be as bad as that data is. So data cleaning will determine how much of quality the information you are getting from your data is. If you don't clean your data and your data is dirty, you no matter how good you are, no matter the kind of technique you use in your analysis, your insights would be rubbish because your data is not of good quality. So it is like garbage in, garbage out. That's why it's very good to clean the data. So if you actually, you probably have heard that most of the 70% of the time of using data analysis is spent on cleaning data. So what are the things that we clean data? Right. Number one, we clean missing values. We duplicate. Let's say outliers, wrong data type, let's say bad formatting. So there are actually a lot of things like that can make your data bad or dirty, right? So these are just the common ones. And missing values is like the most important thing, and it's something that you need to know how to deal with in your data, right? So we're just going to go through this, right? So we are already going, time is going, but we're going to try to just go over this. So we're going to go over how to handle this. So let me start with missing values. Now, the two ways to work with missing values in Pandas is by using two functions, fill NA and what? Drop NA, right? So once we are doing our data exploration, there's another thing we can as well check during our analysis, right? There's something that there are other things we can actually check. Okay, sorry for that. Okay, so we can check if there are missing values in our data too. So we can come here and say retail df dot is NA. So what this is NA does is that it checks, it uses index. Okay, it uses Boolean indexing. It creates a Boolean mask over your data set to check if that particular value is a null value or not. If it's a null value, it will say true. If it's not a null value, it will say false. So if we run this is what we're going to get. So as you can see, this is exactly the output of using this is NA. False. This false means this is not a missing value, not a missing value, not a missing. So we are seeing false, but this doesn't make sense. Like we can't make sense of this, right? So, but how do we now summarize everything to get an idea of how many missing values we have? So the way to do that is just to come here and add up those variables that have true. In Python, true is what? Equal to what? 1, and false is equal to 0. So just know this: true is equal to 1 and false is equal to 0. So let me just give you an idea of what that is. So if I come and say true is equals to 1, I'm going to get true. Can you see it? True is equals to 1. So that means two of them are the same thing. So basically that's just the idea. If I say false is equal to 0, I'm going to get true. Can you see? Hope you are following. Please, can I get feedback in the live class? Hope everybody is following. You can hear me clearly and you're understanding. All right, all right, all right. All right, great. So basically, I just wanted to say that so you understand what I'm about to say. So now, this is NA, create a Boolean ask that we've seen here. So to get a value that will give us an understanding, let me remove this info. To get a value that will give us an understanding of all the null values, we are going to use sum. What this sum does is that it adds up all the true in that particular column. It's going to add all the true values. I told you true is equal to 1. So if in a particular column we have 7 observations that are null, that is missing, it will this particular is NA it will say that it is true. So this sum function here is going to add all those true, and I said true is equals to 1, so it's going to add it together and give us a value. So if I come here and run it, we're going to see it's going to kind of aggregate it, and each of the variable we have a value. So that means this 0 means there is no missing value. There's no missing value. There's no missing value in any of the column. This is actually very, very good for a data analyst. Like, you don't have to stress yourself on working with missing value, right? But what I'm going to do something now, I'm going to quickly modify the data, right, and just get back now. So just give me a minute. I actually am going to just modify the data just to give you an understanding of what how you work with missing. But all right. So let me quickly. Where do I import this? Okay. Go to import it. All right. So I'm now going to rerun this now. As you can see, now we can see that some of the variables have missing values. Price has 12 missing values. Payment method has 3 missing values. Product category has 3 missing values. Discount has 9 missing values. Total amount has 2 missing values. So as you can see, this data has some work. There's some work to be done on it. So we're actually going to look at how we're going to deal with missing values, right? So so I told you that there are 2 ways to deal with missing values. We can use fill NA or drop NA. So we can just come here now and say, okay, I don't want to stress myself at all. Like, let me just drop all the columns or all the rows that have missing value, right? If we check for the retail DF and say shape, I'm going to see that we have 100,000 rows. So if I come and say, let me just drop NA. Drop NA basically means we're going to drop all the missing values. So I'll say retail df dot drop NA. So basically what this is going to drop all the missing value, right? So to drop it, if I run shape on it, it's going to give me, as you can see, is 999, 908. So it has basically dropped about I think 19 or so, 19 missing values from the entire data set. Remember when we run shape that time, it was 100,000. So we've dropped it now, it's now 19. So you can drop it and then we're not going to have a problem with missing values again. Like, yeah, it's something that you can do. But there's something else we can also do. We can actually try to fill in the missing values. In situations where you have a lot of data, like this situation where we have like 100,000 data, it's very okay to just drop the missing values. It won't really affect the result of your analysis that much, right? But when you have little data, it will not be advisable to really drop it. So you try to actually fill in those missing values, find a way to repopulate those missing values. So I can come here and note that as I've done this drop, if I come here and still say retail df dot shape, I'm going to get 100,000 even after I've dropped this NA. Can someone tell me why? I've dropped missing values, but I still run this shape and I'm getting 100,000. So what exactly is the cause of that? Can someone just tell me in the live session why we are still having 100,000 rows? Okay. Okay. All right. So yeah. Remember I told you about what we call in place. In place, right? So in place can be used to make it permanent. So it's very, very important that you know that. If I put in place and run it, it's going to affect the original data set. Or I can just assign it to a new to the data set itself again, like saying retail df, right? So can basically do it like I say to make it permanent, but we're not going to do that because we also have other things to do. So basically that is just it for drop NA. So we can do fill NA. So if I still come here and say retail df dot is NA and run sum on it, I'm going to get this. So I can now individually, maybe I'll now come to price now. I'll now start checking the variable individual and I'll say price retail df. This is data cleaning. No, this is how you usually clean your data. So I'm trying to replace the missing values in price. So I'll come to price and say, let me see price self. Price. Okay, this is price. Okay, it's a float decimal point. All right. So one way to replace missing values, especially for continuous data, for numerical data, is to replace the missing values with the mean of that column. So I can come here and say, let me calculate the mean now of price. Price mean. I'll say np dot mean and say df price. All right, so this is the mean. Okay, I have to import np. All right, so import numpy as np. All right, so you are going to get the mean. If I print it, what exactly is the problem here? Price. For the columns here, price, right? Okay, retail. You guys are actually seeing a live action of how a data analyst is going to approach problems. So these are the kind of error you'll be facing. Most of the errors you'll be facing are just syntactic error, syntax error. Most of the errors you'll be facing are syntax error, right? So as you can see, the one that just happened now. So don't panic whenever you see error. Just calm down and understand what exactly the problem is. So if I print the mean, come here and say print price mean, right? So I'm going to get this. I can just basically say round it to the place. Come here and say 2 decimal place. Put the second one there. right? So it's 4.0. So you can basically just use round here. So it is going to round for me. Or I'll come here and say um, price mean is equal to round price mean and then 2. So I should get what exactly is the okay. All right, so this is you have gotten the mean now of that column. So we can now replace it by using fill NA, replacing missing values with the mean. So now I can come and say retail DF price, and then say fill NA. I will not say price mean. So if I run this, I'm going to it's actually going to replace it. It's actually going to replace the mean. So if I come and say let me assign this to the colon. I'm going to assign this to retail DF price. So it's not every function that uses in place. So the best way to actually make it permanent is always to assign the value to that particular thing you are trying to change. So in this case, we're trying to change or trying to update this price colon. So you assign the newly manipulated or the newly adjusted colon to the old colon. So if I come here and I say retail, if I say retail df dot price, no, sorry, is NA dot sum. You see that price doesn't have any missing value again. Do you get? Like I've already filled in all the missing values in price. So it doesn't have any missing value again. So basically you can do it for all columns individually, right? So you can come to discount apply, do the same thing, come to total amount, do the same thing, right? But in situations where that data is a categorical data, maybe that data is a categorical data, you can replace it with the mode, right? You know, or the particular category with the highest frequency. So for instance, if we check payment method, let's say DF, and there's something I just want to quickly show you before I continue that. You can also use this particular syntax to access a colon dot payment method. So you can also use this particular syntax dot. Remember what we'll be doing is this one that we'll use the data frame with a bracket and the name of the colon, but you can also use dot and then the name of the colon. So I can say, come here and say use dot price to give me the same thing, right? So these are two ways of doing the same thing. That is one thing about Python. So I can come here and say payment method, right? So let me just use that. And you see payment method is a categorical variable, right? I can see cash, which is not a numerical variable. So, and to replace the missing values with mean will not make sense, right? To replace it with mean will not actually make sense. So you can actually check the method with the highest frequency and replace the missing value with that particular category. It's just you might not necessarily be entirely correct, but there's always an error. But you are more the probability of those missing values having that particular category is higher than the other categories. So it's the same thing for the mean. The mean gives you a central point. So replacing all the missing value with the mean also makes sense, and it gives you a higher probability, right? So that's just actually a very neat way of replacing missing values in Pandas. So we are actually going deep. We're actually going into this data analysis like we've started. Like we've never started the data analysis ever. We are just doing exploration and data cleaning. So there are a lot of things that we are going to be talking about in Pandas, right? And I time is actually running very fast. I don't know why, very, very fast. So this is it for missing values, right? So we can use fill NA, and we can also use drop NA. So just have that at the back of your mind. You can always read more of that in the textbook and also in other external resources that we have on the internet. So that's it for that, for missing values, right? So let me just come here. So now, what of duplicates? I talked about duplicates. There are some values or some rules that have duplicates. Removing duplicates. So we can also remove duplicates, right, from our data. So let me just quickly illustrate that. The function we use for that is drop duplicate. So just make sure you know all this function. So we use drop duplicates, using drop duplicates. So to remove duplicates, you can basically, let me just illustrate that with each column. So I'll come here and say retail dot, let's say, duplicates, run it, retail df, right, was it, oh, okay, sorry, drop duplicates. Yeah, so this is what we use to drop duplicate, right? So it automatically drops the duplicate in your data frame. So what it does is that it looks at every row in your data frame and check if there's any row that is similar. So if there's any one that is similar, this particular function will drop the other one and leave the first one, right? So that is basically what it's going to do. So if you have similar or duplicate values, that is what it's going to do. It's going to drop it like that. So you don't need to do any other thing. That is basically what drop duplicate does. So let me just give you an illustration of that using colons, specific colons, so you have a better understanding. So if I come here and say, let me work with product ID, I want to drop the duplicate in product ID. And remember, product ID is a categorical variable, so it won't make sense to drop the duplicate in categorical variables, right? So, but let's just do it so you see how drop duplicate works. So if I say drop duplicates, you see it left us with just 4 values, right? So it basically dropped every other duplicate of C. It dropped every other duplicate of A. It dropped every other duplicate of D. It dropped every other duplicate of B. But you don't use the drop duplicate for this particular data type. I just want to show you how drop duplicate works. You don't use it for a categorical data type, right? You use it like for a data frame of different columns simultaneously, because it's possible that you have a duplicate price or a duplicate something else, right? But if you combine it with other columns, there's a very low probability that you have a duplicate of that. So it will drop anyone that is a duplicate. Another thing that it does is that another way you can use it is for index or for columns that have unique ID, like name, right? Like ID, like maybe patient ID in a hospital or student ID. So it's not possible for 2 students to have the same ID. So you can use drop duplicate on ID or index, or basically customer ID or any kind of ID that it is that is in your data type. So that's just it for drop duplicate. There is nothing, it's actually not difficult to understand. So just understand this drop duplicate function. You don't use it singly on a column. You use it for the data frame as a whole, right? Use that data frame as a whole. And you don't really need to bother yourself about the number of duplicates. You can just, once you run this thing, it's just going to give you, I think there's a function for that. I will try to check and get back. You know, I think, okay, yeah, this is it, duplicated. I think this is the function for getting the number of duplicates. Let me check. So you have to index it. Whenever you run something like this and it gives you a Boolean mask, this is what you call Boolean mask. You are now going to index the result in your data frame. So you get something like this. I don't know why I keep missing that. So you get something like this. As you can see, there is no duplicate. We don't have any duplicate in this data set. Do you get? So that's just it. Like this is the other function we use in getting the duplicate values in that particular data frame. So duplicated is what you use to get it, and then drop duplicate is what you're going to use to drop it. So that's it for the duplicate. So let's move on to the next one. All right. There are actually a lot that we can do during data cleaning that we might not even cover everything. So during data cleaning, you don't only work on the values. Sometimes you might want to transform the column, change the column names, change the column casing, and change indexing, and so many other things, right? There are whole tons of stuff to do during data cleaning. That is why data cleaning consumes the most time during data analysis. Like you spend most of your time doing data cleaning, and that is to ensure that your data is of good quality. Because if your data is not of good quality, the insight you're going to be getting is going to be bad. That is just it. So you have to make sure that you take your time to go through your data cleaning process. So let me just quickly show you something else. Let's assume you have your colon, retail df dot columns, and you have your column names. Yeah. Sorry, I'm going fast because of time. This 2 hours is I don't know, it's even looking short at this point. So we have a lot to cover. So data columns, let's assume you have this, and all your column names are in capital letter, and they have capital letters. And sometimes whenever you are trying to reference a column, let's say retail df, and you say mistakenly put product ID in small letter and something like this, it's going to give you an error, right? Because this is supposed to be in capital letter. Product is supposed to be in capital letter, right? So to just make your life easier, you can just come here and convert all the column names to small letter. It's part of the data pre-processing. So data cleaning and data pre-processing, they go hand by hand. So you can just come here and change all these things to small letter. How do you do it? So this is the syntax, pre-processing and transforming your data. All right, so you can come here and say df, I don't know why I keep saying df, details df dot columns. Then we add something else. We add dot string, right? So you have to get used to seeing several dots for a particular object. So before we've always been using one dot, but very soon you'll be seeing multiple dots, even 3 dots. So it's just like an hierarchy. A particular attribute or method has another sub attribute or something like so. Like the same way we have numpy.random.randint. So there's a kind of cluster to it. So don't get confused by seeing multiple dots. So I want to convert my colons to small letters. So it will be easier for me to just call them or refer to them. So what I use is string. This string function basically gives these colons, the values of these colons, access to some functions, some functionalities, some string functionalities. So we have so many of them. So if you come here and say print, if you don't understand, you can just come and say print dir. Remember dir, your go-to, and you will run it. No, exactly is there. Replace df. So print dir, right? So you get this. As you can see, these are the functions for the string. These are the string functions that you can do. So we have a lot of them, you have a lot of them here, right? So, but what we're going to do in this particular case is just to change the case to small letter. So I can come here and say dot lower. .lower is a function that changes everything to small letter. So as you can see, everything now is small letter, right? There's no longer capital letter anywhere. So it is easier for you to reference them or to call them. So I can just assign this to the colon, retail df dot colons, right? So if I call the retail df, retail, if I say retail df dot head, I'm going to see everything now is in small letter, right? Everything is even better. It looks better, right, than the capital letter, and it looks consistent. So these are just some of the things that you'll be doing with in data processing and data cleaning. So there are a lot of things like, and I just want to let you know something about data analysis. There is no, there are actually set of techniques that you can use, but there's no predefined path to follow. As a data analyst, you have to be creative with the kind of techniques you are using on your data, and you have to allow your data tell you how to handle it, right? So you don't just say, oh, because Mr. Emmanuel has taught us this, Mr. Emmanuel taught us that I'll always use it for all my data analysis. No, like your data will determine the kind of cleaning and the kind of transformation that you do. So data analysis and data science requires creativity too. You have to come up with ideas of how to work with your data. So the way to be creative is to read, to learn new functions, to work with data, to practice it, to help you to build intuition on how to work with your data and how to do data analysis. You can have all the skill of a data analyst. You can learn how to remove missing values and everything. But if you are not creative, if you don't have that ability to read your data, you will not be a good data analyst. You will not be a good data analyst. So that is just what I'm going to be ending with for today. There are other things we are still going to discuss. This is not the end. As I said, we have stages, and this one is the data cleaning and preprocessing stage. We also have the exploratory data analysis, which is the main analysis, right? Which is the main analysis. And then we'll move on to the other one. So tomorrow we'll just be concluding with exploratory data analysis, right? Is when we start machine learning that we're now going to be looking at feature engineering, data modeling, and analysis. So for today, we're going to be stopping here, and I'm going to be taking questions. I'm going to be taking questions. All right. So hope everyone can still hear me. Hope everyone can still hear me. All right, great. So I'm going to be stopping here for today. We are almost out of time, right? So I've given enough time for questions. Tomorrow we continue with the rest of Pandas, right? So we'll be continuing with this particular data analysis. We'll wrap up with it and we'll enter data visualization. That is where we are going to be data visualization is part of exploratory data analysis. Like you're using visuals to explore your data to get insight. You can as well use visualization for other things like cleaning, data cleaning, and other things. So, but tomorrow we're going to look at that. We're going to look at matplotlib, which is a library. So I will be introducing a new library tomorrow, a new library called matplotlib for plotting visualizations or for plotting graphs for visualization in Python. So far we talked about NumPy, we talked about Pandas, and tomorrow we'll be introducing matplotlib. And in the subsequent weeks, we're now going to be introducing a machine learning library called scikit-learn. So there are lots to learn. So make sure that you are up to date with what we are doing, so you don't feel left behind, because there are a lot of things to learn in data science. There are a lot of things to learn, a lot, trust me. Even I myself, I'm still learning. Right. So before I take questions, I'll just quickly, I remember I told us that I was going to, show us how to download data, like access data from the internet, in case you are looking for where to work or where to get data from. So there's what we call Kaggle. right? Let me quickly open that. All right, so there's what we call Kaggle. Kaggle is a website, is a kind of community for data scientists. So I want every one of us here that can hear my voice, that is in this class, to have a profile or to open or sign up on Kaggle. Kaggle is, especially for data scientists, Kaggle is where you interact, you see a lot of things that has to that relates with data science, right? So open an account with Kaggle, and I will show you exactly how to explore, how to get data set, and so many other things. So if you type Kaggle on your Google search bar, you'll see it coming here as the first result. So just click on the first link that you see there, right? So it will take you to somewhere like this, right? So I'm already signed in, right? So here's what you're going to see. You're going to see by your left-hand side, you see the menus: home, competitions, data sets, models, code, discussion, learn, and more, right? So for data sets, you just click on this particular place, click data set, right? So it will take you to this page where you see lots of data sets. So basically, Kaggle has plenty data sets, like a lot of data sets. This particular data set I'm using for this class, I downloaded it from Kaggle, right? So you can see here, you can even filter based on your choice, right? So you can come here and click filter. You see the file size, see the file type, CSV, JSON, see so many other things, right? You can actually filter for the kind of data you want. So if you come here, you see different, let's just pick one data set, right? Let's just pick this particular one and open it. Fitness tracker. All right. So this is what you're going to see. Once you open it, you're going to see the first page. You just have to scroll down. Scroll down so you now see the data explanation, right? So you see the explanation of the data, right? You see the variables, user ID, dates, total distribution tracker, so many other things. If you want to download the data to your computer, you just come here, click download. You download data. You can do analysis on it. You can practice. You can do anything. So there are lots of data for you to practice. A lot. Like the Kaggle is where you want to be as a data scientist. Trust me, where you want to be. There's also competitions, a lot of other things, right? So yeah. So this should be your TikTok or your Facebook, depending on what you use. Some of us might not use social media, but this should just be your social media, basically. So that's it for that. So in case you are looking for where to get data sets, you already have Kaggle, right? So all right. So that is going to be it. I don't know if I have any other thing to say. Okay. All right. Questions, please. If you have any question, I would like to take them now. All right. Let me go from here. Please raise your hand. I'll be picking you. All right, Isaac. Isaac, you're on mute. You can go on to ask the question.
Let me now, sir.
Yeah.
Okay. Thank you for this class. My question is in regards to creation of a new column in a table or a data frame. What if we want to create a new column in between two already existing columns? How do we run the code for that?
Sorry. What was the last thing you said?
I said if we are to create a column in between two already existing columns, instead of, like, I don't want to create the column at the end of the table, like the last column. I want the column to come in between two columns that are existing already. How do I run a code to do that?
Okay. Yeah, that's a good question. Is that the only question you have? So
Yes,
I'll answer everything at once because of the time.
uh, it's just that one.
All right, good. So you can actually, yeah, you can actually create a new column toxicity, right? So there are a lot of things you can do. The thing is that the possibilities in pandas are endless. So let me see if I can remember the function, right? So let's say I have my retails df, right? So I have my retails df, retails df. All right, so let's assume I want to put a colon here in between product ID and quantity quantity. So I'm going to use insert, I guess. Okay. So I'm going to use insert now, and the first argument here should be the location, index location. All right. So this is 0, 1, and then 2. So it should be 2, and now to create a column for this. Okay, let's say a new column. New column is equals to mm, df new column. So let's say I want to use price. Let me just say price. Um, price plus 5, right? So um, can actually just come and say, okay, I'll just have to put in the new column name. Okay, so I think I would put in this here. I just hope this works because I'm not too sure of this syntax. Not too sure of this syntax, but I will colon. Um, okay, I can say, I can come here and say data, and then put it here. Then I say retail df dot add. Okay, I'm performing the operation multiple times, so I have to run the entire thing. So let's just have patience. I believe everyone is learning here. So it's good as you are seeing my thought process. So sometimes you might forget a particular thing, but so you just have to try. So let's run that again. So I would come and so I have to rerun the entire thing again. So the reason why it's giving me an error is because I've inserted this new column already. So I'm trying to reinsert it again. So it's giving me an error. So let me just wait for this to restart. And then, so yeah, but that's a good question. That's exactly what it is. So we do the oh, okay. So a lot of things I didn't do here. Let me just insert. All right. So as you can see now, I've inserted a new column here in between product ID and quantity. That took a long time because of some errors. But basically, what you do is use insert. There's a function called insert, and it takes in three arguments. It takes in two. Two is the index of where you want to place it. So you have to know where you want to place the new column. So the index says two in between product ID and quantity, and then this second argument is the new column name, right? And this data is the data you want to use to populate that new column. So in this case, let's say you want to, let's say for revenue profits. Now we have profit revenue and cost. So we want to create a profit column. So this is how we're going to do it here. I want to insert it like after profit and revenue and cost. So this is basically how we're going to do. So not every time that you have it at the end, right? So that sometimes you want to specify the location. What you're going to use is insert, use insert, and then this following argument. So yeah, that's a good question, and I believe you are clear on that.
Yes, I'm
Hello?
clear now. Thank you.
All right. So any other question? Yeah, Mr. Ma, please go on. I'll take two more questions because of time. Yeah, Mr. Ma, you can ask your question. I don't know what's happening, if it's network or you can't hear me. But yeah, so that's going to be it for today's class. I believe you were able to get one or two from what we did today. So there are actually a lot in Pandas, and we've just taken the tip or touched the tip of the iceberg that we are going to be continuing tomorrow. But we won't exhaust everything. So you have to go on your own to read and to practice questions, different examples, and even use these examples I've given here to just go through them again and try to understand the logic behind them. You get familiar with them. So you just get comfortable with using Pandas generally. So it might look daunting initially, but definitely with time you get comfortable with it. All right, so I'll just take Philip's question and then call it a day. So you're on mute, Philip. Please ask your question. Okay, so let's just end the class now. I don't know why nobody's saying anything. All right, so if you have any question, you can just ask in the group chat. All right, so that's going to be it
Can
for
you hear
today.
me?
See you tomorrow.
Hello.
Yeah, I can hear you.
All right, Mr. Emma, good evening. Sorry, my mic, I was just trying to get it fixed. All right, thank you for the session. I'm really enjoying your sessions. Thank you. Okay, I have a couple of questions here. I think I just need clarity on it. Now, in that part of let's say when we are saving in place, the use of that in place. Now, if I was working on a particular data and now discover there was an issue or so, and I want to, let's say, undo that part, or maybe go back, is there anything like a save point where I can actually go back there, or I have to go and maybe go back to the beginning and maybe reload the data again or so? That's one. Then you mentioned this data analysis. I just also want to confirm. We are touching data analysis. It's also we get to machine learning and the others there. For a person that is actually focusing on data analysis and machine learning, and we that we are doing data science, what is the level or the depth we are going to? Can we boldly say, okay, data analysis, machine learning, okay, I already know what they are doing, or we are just touching the surface? Okay, or that is for that. Then for also this Kaggle, you made mention of Kaggle, for data, getting those data set. Now, let's say the data that is being provided there, are they really genuine or they are just generated by the systems? Because sometimes, like I've been in a situation where someone wanted to work on a project and they were like, okay, where are you getting your data from? The person said Kaggle, and they said no, they can't accept that. They has to go get a fresh data set. So the ones in that Kaggle, I would like to know if it is just generated by a machine or it still has some level of authenticity. Thank you. Over to you.
Okay, I'm really sorry. I think I missed from your first question, but the last question, I don't really know the situation in which that was said, but most of the data sets on Kaggle, they are usually curated by people, right? And but just the thing with Kaggle, some of Kaggle data sets is that some of them are already clean. I think that is why the person might not necessarily want you to use want that Kaggle data set. Some of them are clean; they don't really have a lot of issues. So it's just something you just download and go straight into data analysis. You won't have to go through the process of data cleaning. So it doesn't replicate entirely a real life data, because a real life data would have a lot of mess around, to be very, very messy, right? But Kaggle data, not all, some of them are already cleaned. They don't have missing values, they don't have duplicates, they don't have most of what it is, but not all of them do. So, but it's actually a very good place to also try your hands with something. And you can as well create create these things by yourself. You can go to Excel, delete some rows in that data, try to replicate missing values, like a data that has missing values. Just do a lot of things. So Kaggle data is just for learning purposes. It's just for learning purpose, just to help you understand and deal with all these things that we are learning, right? So yeah, that is it for your third question. You said something about in place for the first question. Please, can you just recap? I didn't really.
The second question was for a person that is actually running data analysis, like data analysis full time or machine learning and AI, like compared to us that are running data science. Okay, so what level are we operating? Are we in data science? Are we just touching the surface, or we are also going deep? Okay, are we also going deep? That okay, if we stay with.
All right. Okay. What was the first question about in place?
Okay, the first
I think I heard something.
Yes, that's in place there. I said, okay, like a case where we just introduce maybe a new column to let's say our data frame.
Okay, yeah, I think I remember the breakpoints, something about breakpoints, right?
Yes, like a save point where we can actually go back and do and maybe make a correction there.
All right, let me just quickly answer this one. So for the breakpoints, if you listen very well, I said it is very important to know when and when not to use in place. If you are doing your analysis, you should know when to use in place and when not to use in place. So you don't just use it anyhow. You should make sure you are careful with using that. But there's also something else you can do. You can actually create copies of your data. You can create copies and just at different points just keep them in case you need to go back. So that is actually a manual way of creating breakpoints. I'll show you how to do that like as soon as I've answered the second question. So your second question, data science is actually all encompassing. Data science encompasses data analysis and machine learning, right? So if you're a data scientist, what we are doing in this program, we are giving you guys the fundamentals of data science. So everything you need to know, right? So, but is it not possible to get or to equate yourself at this level with someone that is already deep into it? So there are some people that are data scientists, right? They started as data scientists, but as they were moving on with their career, they started branching out to specialize in, let's say, machine learning, or branch out to specialize in something else. Like, so data science is all encompassing. Is a field that has so many things, right? So you can call yourself a data scientist and you're working on AI, you are building AI models, but you're a data scientist, right? So it depends on how far you want to go. It depends on what you want to do too. So you can all these things are just it just depends on you basically. So that's it for that. And I don't know if I understood that question clearly to answer it accurately, but that's just what I think about that. All right. So for the breakpoints that you talked about, what you should do is that whenever you get to a particular point in your data set and you have your data retail, you did a modification, you can just copy your data. You can just create a copy and say copy and say retail df dot copy. So what this dot copy does is that it copies this data into this variable, right? So you can just keep it. Let's say you now make mistake with this particular df, you can always come back to this copy and reassign it to a variable. So you can have, let's say, at different points, copy 1, copy 2, copy 3, copy 4, right? So in case you have a need to go back to a particular point, this is when you have you are doing an analysis and your analysis is very lengthy. So it will be stressful going back up to reload your data. So you can create copies of your data set. But sometimes if your data set is very large, it can be memory consuming because you have multiple copies of your data set in memory. But that is actually a way to do that or to create breakpoints and to track back. Right. So that's it for that. I'm going to be ending this session now. If you have any other question, please just let me know in the group chat, and please let us know how the class was for you and what you learned, and just share your experience with today's class. And I hope to see you all tomorrow too by 5 p.m. Thank you very much for your time, and God bless you.